This is part 3 recording of the cout object functions topic. In the previous part 1 and part 2 recordings, I talked about width function, fill function, precision function, setf function, unsetf function, and also the iOS flags. Here the focus is on the put and write functions belonging to cout object. In this code I have a student struct with id, name, number of marks, and marks data members, and in the main function I have a statement to create an array of student objects of size 2, where the first object is initialized to this data and the second object is initialized to this data. I will use this code to try to understand the topics better. The first topic of focus here is put function that comes with cout object. This is a function for displaying a single character. So you could put out a single character like this. This will put out C, plus, plus, C plus plus. Then I want to actually put out a new line. So this should display C++, and the cursor should move to the new line. Let me show you what would be the output of this code. By compiling and running it in the terminal, I would ignore this warning because we have not used this array, so it is displaying warning. That's fine. And compiling, you can see C++ displayed. Back to the code. Now if I want to display this name, then what I would do is I can create a character pointer to point to that this array, specifically to point to the first character of this array. So the address of the first character of that array can be evaluated through the first element of this array dot name and the first element of the name, and this name itself is either you could do something like this, or the name itself is the address of the first character. Therefore you can set cptr to this value. So now cptr is pointing to the name of the first object, and what I can do here is, while I would pick one character at a time and display using put function until it we get a null character, which is actually just after the character n. So while you use this expression to access the data not equals to null character, then I would just call that function put, and then one thing, this statement will actually display that particular character it is pointing to, but we need to also increment this so that in the next iteration it will point to another character, and another character, it will go that way, right? So we need to increment the pointer. So this will actually display the entire character, string, this name, and at the end I want to actually new line character, so that the next thing that is put out will be displayed in the next line. Let me check this code in the terminal. Its output. We compile and link. We execute. Now we have C++ was displayed in the previous line. Jackson is displayed here. So back to the code. One of the purpose of or the advantage of this put function is that it gives you precise control over the characters in the output. If you are using cout statement like this, st00 dot name, you could also display the same name using this statement, but you cannot control the characters. For example, if I want to display entire string by uppercasing, by making k character, whenever it comes, display k character uppercase, otherwise uh, display all the other characters the way they are. In that case, I could put if condition, if it is lower k, then you actually put out the uppercase character version of that. Otherwise, just display the way we just displayed before, right? So we should be able to manipulate one particular character, select one character and manipulate character. That we cannot do with this cout statement. Let me see the output here. Now you can see this k has been uppercased in the display, but cout statement, this is the outcome of the cout statement. We cannot pick one character and change it. Now also, for example, if I want to instead of displaying this space, if I want to separate this to first and last name by some character, let's say asterisk, in that case also we can make use of this function like this, if else, and you can have another else if condition. If this is a space, then asterisk, right? So this is the change I made here. Let me check the output for this particular case. Now you can see we are able to use our own character to separate the first name and last name. So yeah, now having discussed put function, the time we want to discuss another function which is called write function. So this is the write function, and the signature of write function is in the first it has a parameter of const character pointer type, and second is type. So this is a signature. Here Stream size is a type designed for the count of characters. Number of characters transferred in an input and output operations, or the size of input output buffer. Those are the things that are actually expected to expected to be stored in a variable that is of type this size. So and basically this is a signed integer type. You can compare this with the integer type. So don't worry about this at this point. It is just, you can assume that it's another name for the integer type, right? Now this function displays a specific number of characters. For example, particularly this n number of characters beginning from the address, the the address that this pointer is pointing to. So when I say, but it displays in an unformatted way. Which means that it does not see whether there is a number, there is a string, there is a float, or other types. It just sees everything that it is displaying as a characters, a sequence of characters. So it will go to the address. For example, in this case, if this is pointing to this this element, then it will go to address and pick the characters one by one, and it will continue picking until this n number of characters are actually displayed. So just let me show you how does it work for this particular, for displaying Jackson's action. First I would provide the address. This PTR receives the address, so address of 0 name. This is the address of that name of the first student, and I want to display, let's say, 5 characters. And new line after that. So switching to the terminal, you can see it was it actually went to this address and it started picking up character one by one, and it displayed 1 2 3 4 5. If I change this to, let's say, 12, now total 12 characters are picked and displayed. If I select 15, it should display the entire name. Right? But if I select the larger number, then it will continue. Whatever the thing is available after this, the address of this n, it will continue picking and displaying those things, right? For example, 20. Let me use a 25. So it displayed, but the characters that are not displayable, so probably the nothing is there. But if I increase this to a bit higher value, let's say 100, and there is something displayed after that. right? So it will continue picking off the characters, I mean byte, whatever that is placed in the byte, and display it on the output. So the one advantage, why do we need write instead of cout, right? So the advantage write gives is it gives you precise control over the number of characters. In the case of put, it gave you control over the characters, but in this case it gives control over number of characters you want to display. Next, I mean one of the I mean another advantage that this control provides you is one of the example that where you have you will find this control over the number of characters useful is in dumping the bytes uh, to the terminal, to the output, the bytes from a memory to the output, right? So the example I'm going to be using here would be, for example, I have int x equals to, let's say, 724255585, right? We have 7242555. Okay, now I want to uh, write it, because this is integer data, so it would have been written in 4-byte memory space. So 4-byte means equivalent to 4 characters memory space, because one character requires 1 byte, so 4-byte 4 character. And we start displaying from the address of x and 4-byte, right? But in this case there is going to be issue problem, because this is actually the integer pointer, but it is expecting the character pointer. So you need to cast this into the character pointer, then it should display something. Let me see what it displays. So it has displayed a C++. Right. So why it is displaying a C++? Let me explain it. First, I want to see what is actually stored. I mean, what is the binary version of this one. So for that purpose, I am using its binary version. We have a function that I'm using as a tool here, bit set. I want to map this x into 32 bits, that means 4-byte. And to use this bit set, I need to include the library. So this will give me access to the I mean we will be able to see what is actually in the memory space for this variable x. Let me clear, compile link, and execute. So this is the thing that is stored in the memory, right? If you look into this, for example, if you select 1 2 3 4 5 6 7 8, so these bits these are the ASCII representation, the ASCII bits for this character A. So it actually picked these bits and it dumped into the output stream, and then after that it picked this bits. I think this is 1 2 3 4, yeah, this bits, and dumped. And after that this was C. This is a ASCII code for C, and this is ASCII code for plus, I guess. I think this should be ASCII for plus 1 2 3, yeah, the 8 bits, right? So and this should also be ASCII code for plus. So it was one byte was picked and dumped as a character. Another byte was picked and dumped as a character C. Another byte was picked and dumped as a character C, and another byte was picked and dumped as a character C. Okay, that is all I wanted to talk about these topics. Thank you for watching.